Okay, so in this video, we are going to talk about applications of quadratic functions. And what this is doing is these are the word problems. There are many situations in real life that utilize a quadratic equation to help find solutions for them. Most notably, things that we can obviously think of is kicking a soccer ball, hitting a golf ball or a baseball, kicking a football, launching a rocket, a toy rocket up, it's going to come back down. Any of those follow kind of that parabolic or that quadratic shaped graph. Now, generally, when we are looking at quadratic equations or quadratic applications, we're looking for one of two things, maybe both. One is the vertex. They're going to want to know where that maximum or minimum is. If they're asking you to find a maximum or a minimum, or that they use verbiage like that, you're looking for a vertex. More often than not, you're going to be using that negative b over 2a, f of negative b over 2a formatting. You could also possibly be looking for the x-intercepts, and that is because in most of those scenarios, like kicking the football or launching a rocket or things like that, the x-intercepts or that x-axis represents the ground. So you're looking for when it hits the ground, stuff like that. Now, one thing to be mindful of is the units that the equation is being measured in, and making sure that that makes sense or interprets properly into the answers that you were looking for. So the first example that we're going to look here is they want us to find the minimum product of two integers whose difference is 10. Okay, so they want us to figure out what these two integers are. So we've got a couple of things going on here. So it said they want us to minimize a product of two integers. So I'm going to say that P is my product, two integers. I'm just going to use X and Y here for my integers. And so then they said that the difference, so difference means subtraction, between these two integers is 10. So we've got X minus Y is 10. Now, I've got too many equations running around right now. And so what we're going to do is we're going to solve one of these equations, and we're actually going to work with this one, and we're going to solve it for one of the letters. So what I'm going to do is I'm going to add this Y over to the other side. So now I have X equals Y plus 10. Okay. And now I'm going to replace the X in this equation with what I know it's equal to over here. So now I've got P equals Y plus 10 Y. Now, distribute. And we've got something that looks like this. And now this is very traditional, quadratic looking. So since I did say that they wanted a minimum, we are going to find our vertex. Okay, so we're going to do negative b over 2a. So it's going to be negative 10 over 2 times 1. So that's negative 10 over 2, which is negative 5. Now, this is my first integer. Okay. So now, if I plug this back in, negative 5 squared is 25 minus 50. That gives me negative 25. This is the minimum product. Okay, so now the question is negative 5 times what gives me negative 25? And the answer there is 5. So this is my second integer. Okay, so we would have negative 5 and positive 5 as our two integers. Those are 10 apart, so the difference would be 10. And we have that the minimum product would be 25. So now let's take a look at another example. Okay, So for this one, you have 120 feet of fencing to enclose a rectangular region. They want us to find the dimensions of the rectangle that will maximize the enclosed area. Okay, so we'll take a look at this one. So first off, I have a rectangle. Let me draw myself up, pretty little rectangle here. And we know two things. They want us to do area. So I've got a length and a width. So I'm going to use L and W. So length times width is my area. And then I have a perimeter. Now, perimeter, again, is all the way around. So if this is a length, this is also a length up here. If this is a width, that is also a width. If I add up all the way around, I have 2 L's plus 2 W's. And I also know they told us I have 120 feet of fence, which will be my perimeter. So I have 120 equals 2L plus 2W. So now, very similar setup to the one we had last time, slightly different operations going on here, but I still have that multiplication equation, and I have one that's a little bit simpler. So I'm going to work with solving this one, and I'm going to solve for one of the letters. It doesn't matter which one. I'm going to solve for L. So I'm going to start by subtracting my 2W. So now I have 120 minus 2W equals 2L. And then I'm going to divide by 2. So 120 divided by 2 is 60. 2 divided by 2 is 1, so it'll just leave me a W. And that's my length. And again, I'm going to replace this L with what I know it is down here. So now I have area equals 60 minus W times L. Sorry, excuse me, times W. I'm going to distribute. So I have 60W minus W squared. Now, I do want to get this in a more traditional order, but I do need to watch my signs here. So my W squared is negative. So I'm going to write that way. My 60W is positive. So I'm going to make sure to write that there. And again, they wanted us to maximize our area here. So we're going to do negative B over 2A. So I've got negative 60 over 2 times negative 1. So that's negative 60 over negative 2. That is 30. Now, since this was W, that's my width. Okay. Now, this is one of those situations where we can use our geometry knowledge to help us out. If this width is 30, then this other width on this side, because it's a rectangle, must also be 30. Now, that means I've used up 60 feet total. So if I take that 120 feet that I have, and I subtract off the 60 feet that I've already used, that leaves me 60. And that has to get divided evenly between the two sides, which means both of these are also 30. So we're actually building a square. Now, if I want to know my dimensions, we're doing a 30 by 30. And that area is 30 times 30, which is 900. Now, you could have also found this area by plugging this 30 back into this equation. If we had done that, negative 30 squared plus 60 times 30, it's negative 900 plus 1800, which is 900. Notice, same answer here. Okay, so you've got a couple of different options when it comes to the rectangle problems. Or similar style with these. So this is the first couple of types of application problems that we see.